So today we will be dealing with the numerical problems. Okay, today we will be dealing with the numerical problems. Those are associated with all the three modes of heat transfer, including conduction, convection, and radiation as well. Okay, yeah, so we have a variety of numericals which will be involved in this particular session. Okay, right from calculating the Fourier's number, to Reynolds number. Then we are going proceeding with the radiation heat transfer. So what is the Stephen Boltzmann constant? How the radiation heat transfer occurs? Then what is the like the concept of heat transfer coefficient, convective heat transfer coefficients? Okay, yeah, so we will be dealing with all these variety of numericals in today's session. Okay. Yeah, so chalo, let us start with the problem statement number 1 for today. Okay, have you attempted solving the questions? Yeah, anyone?
Yes, ma'am.
Okay, okay. So
Yes,
are you
ma'am.
getting the answers?
Yes, ma'am.
Yes, ma'am.
Okay, fine, fine. So let us cross check whether you could solve it correctly or there are any modifications while solving the particular problem statement. Okay. Yeah, so before we proceed, I will share my screen with you people. Yeah, so is the screen visible?
Yes,
Yes,
ma'am.
ma'am.
It's
Yes, ma'am.
Okay, yeah, fine. Yeah, so chalo, let us proceed with our today's problem statement number 1. Okay, can you see the problem statement here? Okay, yeah, so let us just go through the problem statement first. Before we are going to the problem statement, let me know how many of you have been able to solve the particular question and what is the answer. Okay, 0.05574. Okay, okay. Anyone?
Ma'am, my
Any other
answer
answer?
0.223.
0.027. Could you solve? Yeah. 0.
0.0278.
Okay, fine, fine. So as we can see, we have variety of answers today. Okay, yeah. So today let us see whose answers are correct. And for those whose answers are not correct, where you have went wrong. Okay, yeah. Meanwhile, I would like to repeat for those who are appearing for men's, we will be writing the given terminologies first and followed by the to calculate parameter. Okay, that will be for the men's. And second thing I would like to mention here is कि जहां जहां पे हम लोगों का मिस्टेक हो रहा है, ओके, वेदर एक बंदे का मिस्टेक है, आप लोगों में से किसी का मिस्टेक है या फिर मेरा मिस्टेक है, okay, let us just discuss on the mistakes, okay, so that we will be able to avoid the mistakes as far as possible, okay, while we are attempting for your examinations. Okay, yeah. So the
yes,
problem statement number 1 is a 50 millimeter thick pack of farm fresh berries is cooled at one side from 24 degrees Celsius to 7 degrees Celsius. The relevant properties of berries are density has been given as 1025 kg per meter cube. We have been provided with the specific heat. What is the specific heat here? 3.78 kilojoule per kg per Kelvin. We have convective heat transfer coefficient as 30 watt per meter square per Kelvin and thermal conductivity of 0.3 watt per meter per Kelvin. Now what we are supposed to calculate? The Fourier number. Okay, we have been asked to calculate the Fourier number for a cooling span of 30 minutes. Okay, yeah. So what is given to us? As we can see, we have been provided with the density, specific heat, convective heat transfer coefficient, as well as thermal conductivity. Okay, so what we will be doing? We will pen down first. Okay, we will pen down first, which is provided. Okay, which is provided. So given is, yeah, even the time span. T is equal to 30 minutes. So convert it to seconds, 30 into 60, right? The length has been given as 50 mm. So we are following the SI unit system here. So we will be converting all the parameters into meter. So L is equal to 50 mm Okay, then the rho is nothing but the density, and Cp is given as 3.78 kilojoule per kg per Kelvin. That is the specific heat. Okay, that is the specific heat. Okay, yeah. And the value of K is, I missed out penning it down. The value of K is 30 watt per meter square per Kelvin. Okay, so again, we will be converting all the parameters in one single unit system. Okay, we will be converting all this in one single unit system. Okay, yeah. Sorry, that is thermal conductivity. I missed it out. The value of K, the value of thermal conductivity is 0.3 watt per meter per Kelvin. Okay, yeah. So these are the things which has been given to us. Now we are supposed to calculate the Fourier number. Okay, we are calculating the Fourier number. So what is the formula to calculate the Fourier number? F0 is equal to alpha t by L square. Okay, F0 is equal to alpha t by L square. Okay, since we know the value of alpha, sorry, even this can also be written as KT divided by rho Cp L square. Yeah, we have this formula. So alpha could be calculated as, the value of alpha will be K divided by rho Cp. K divided by rho Cp. So we have the value of K as thermal conductivity. The value of K is the value of thermal conductivity, that is 0.3, the value of density and the value of Cp. So pen down the values and calculate. And let me know whether you are getting the value. Okay, so the value of alpha here will be 7.74 into 10 raised to minus 8. Okay, 7.74 into 10 raised to minus 8. Putting this value in F0, or even you can put all the values in the formula of F0 as such. Okay, for the formula of Fourier number, you can put the values as such. The value of K, the value of T, the value of rho, value of Cp, and the value of L square.
मैम डायरेक्ट फॉर्मूला में रखने में आंसर आ रहा है 0.055 तो
Yeah,
सही
yeah.
है
Yeah, that's true. That's correct
Okay.
as well. No worries. That is what I'm telling. Even you can put all the values in the formula initially as such. Okay, everybody's getting the value. Those who could not get the value,
Instead of L square, I used L. So that's why.
okay. Yeah, so what you have to remember here, thoda sa gadbad while we are writing the formula and we are getting the wrong value. Okay. Others, where have you went wrong? You just can share.
Ma'am, the L we have taken, is it characteristic length or just the length given? I took
The
characteristic
length given.
the length given. Okay.
Yeah. So let us move on to the problem statement number 2 here. Okay. So the second problem statement we have. Okay. So before I proceed, everybody got the answer?
Yes, ma'am.
Okay, fine. So the second problem statement we were provided with is with respect to the net heat transfer. हम लोगों को net heat transfer calculate करना था, and the particular formula or the typical problem statement deals with the heat transfer with the mode of radiation. Okay, with the mode of radiation. So it is a very simple problem statement. We can get the answer very easily. Okay, so let me know, all of you, did you get the answer?
Yes, ma'am.
Yes, ma'am.
6.6.
What is okay?
6.7.
Others?
6.7.
67.29
6.7.
67.29
Okay,
67.29
67.29. Okay, yeah, fine. So let us just go to the problem statement. And I guess यहाँ पे digit point ka variation I could see. Few of you are getting the value at 6.7 something and others are getting the value in terms of 67 point something. Okay. Yeah. So let us just go through the problem statement first. Okay. Yeah. So heat is transferred by radiation to loaf of bread in an oven at an uniform temperature of 177 degrees Celsius. The total surface area and temperature of the loaf are 0.0645 meters square and 100 degrees Celsius respectively. The surface emissivity of the loaf is 0.085 and the value of Stefan Boltzmann constant is 5.67 into 10 to minus 8 watt per meter square per Kelvin raised to the power minus 4. Okay, the net heat transfer W is we are supposed to calculate. Okay, तो हम लोगों को क्या क्या दिया है यहाँ पे? We have been provided with the Stefan Boltzmann constant, emissivity, epsilon का value दिया है. Then हम लोगों को initial and final temperature दिया है. We also have been provided with the surface area. Okay, we also have been provided with the surface area here. Okay, so which formula we'll be using for this particular problem statement? Can anybody tell me?
Radiation heat equation.
Yes,
Q
so
is
we will
equal
be,
to A.
yes. So we will be using the formula as Q is equal to epsilon sigma A T1 raised to the power 4 minus T2 raised to the power 4. Okay,
Yes.
yeah, so let us just go through one by one. Yeah, so we will be penning down first what is provided. Okay, what is provided. Okay, so given values are epsilon emissivity is 0.085. Okay, the value of sigma. Sigma is Stefan Boltzmann constant. Yeah, which 450? Yeah, we will be reaching there one by one. Okay.
ma'am.
Yeah, we will be reaching there one by one. Okay, so the value of sigma is the value of Stefan Boltzmann constant. The value is 5.67 into 10 to minus 8 watt per meter square per Kelvin to the power 4. We have the value of T1 as 177 degrees Celsius. Okay, the value of T1 is 177 degree Celsius. So we are converting it into degree Kelvin. Okay, so how to convert it to degree Kelvin? Just add with 273. You get the value in the terms of degree Kelvin. Okay, that is how your T1 comes out to be 177 plus 273 is equal to 450 degree Kelvin. Got it?
Yes, ma'am. Yes, ma'am.
Okay, and same applies to T2. Okay, wherein T2 stands for 100 degrees Celsius. Add 273, you get the value as 373 in degree Kelvin. Okay, now what we have been asked to calculate? We have been asked to calculate the net heat transfer. We already have the formula to calculate. Okay, Q is equal to epsilon sigma A, T1 to the power 4 minus T2 to the power 4. Okay, just put down the values and get the answer. Just put down the values and get the answer. Let me know everybody has got the answer.
Excuse me, ma'am.
Yeah.
Ma'am, the epsilon you are using in the formula is 0.085 instead of 0.85 now.
Okay, fine.
So, ma'am, that's why my answer is coming out to be 6.73.
Okay. Yeah, so we will correct it. You're getting the value then?
Yes, ma'am. 6.7.
Okay. Okay, fine. Others?
Yes, ma'am, same. 6.73.
Okay, fine. Everybody's getting the same value?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So let us proceed to the next problem statement we have. So the next problem statement deals with the unsteady state heat transfer. Okay? Yeah. So how many of you have been able to solve this particular question?
I'm solved, but don't know the answer. Whether it's correct or wrong.
Okay, fine. What is the answer did you get?
286.88.
Okay,
Yes, ma'am.
fine.
100,
Others?
200.8.
78, ma'am.
Okay, okay. Okay, fine. So let us just we will solve the particular problem. Okay? Yeah, so I'll just read out the problem statement. A meat ball with a radius of 25.4 millimeter at a temperature of 700 degree Kelvin, it suddenly plunged into a medium whose temperature is held at 395 degree Kelvin. Assume a convective heat transfer coefficient of 11.5 watt per meter square per Kelvin and take the average physical properties as K is equal to 44 watt per meter per Kelvin, density as 7850 kg per meter cube, and the value of Cp, specific heat, as 0.4606 kilojoule per kg per Kelvin. Okay, now what you have been asked to calculate? You have been asked to calculate the temperature of the meatballs after 1 hour. Okay, we have been asked to calculate the temperature of the meatball after 1 hour. Okay, yeah, so let us let us paint down what has been given. Okay, what has been given. So this is, as I already have stated, this is the problem statement related to unsteady state heat transfer. Okay, so the given is TA as 395 Kelvin and TI as 700 Kelvin. Okay, yeah, then H is equal to 11.5 watt per meter square per Kelvin. A, the formula of A is 4 pi r square. ठीक है, हम लोगों को radius already दिया है, so the value of radius is 25.4. We can convert that into meter. Okay, so 0.0254. The value volume will be 4 by 3 pi r cube. Okay, so I'll just explain why I am putting the values for area and the value for V. Okay, yeah. And the value of density has been given 7850 kg per meter cube. The value for Cp is 0.4606 kilojoule per kg Kelvin. So we'll be converting it to joule. Okay, so 460.6 joule per kg per Kelvin. Okay, now we know the formula for unsteady state heat transfer. Okay, what is the formula? Ta minus T divided by Ta minus Ti is equal to e to the power HA rho CPV by T. Okay, HA rho CPV multiplied by T. Now, इसमें हम लोगों को क्या calculate करना है? We have been asked to calculate the value of T after time T. Okay, we have been asked to calculate the value after 1 hour. Okay, so the value of capital T we will be calculating at the time interval of small t. So what will be the small t here? 1 hour. Okay, 1 hour. So convert it to second, 1 hour into 60 into 60. So the value of small t here will be 3600. Okay, yeah. So let us pen down the formulas for area and the formulas for volume. Okay, so this is since this is a mid ball, okay, since this is a mid ball, the geometry will be that of a sphere. Okay, the geometry will be that of a sphere. So what is the formula for area of a sphere? Is 4 pi r square. Okay, and what is the formula for the volume of the sphere? Is 4 by 3 pi r cube. Okay, so substitute the formula.
6 by
Numerator
D.
and denominator, yeah.
6 by D.
Pardon?
Nothing, ma'am.
Okay, fine. Okay, so substitute the formulas and you get the value as Ta minus T divided by Ta minus Ti as e to the power minus h into 3 divided by rho Cpr into T. Clear till this point?
Yes, ma'am.
Okay, fine. So moving on, we will be putting the values. Okay, we will put the value for Ta, we'll put the values for Ti, we will put the values for H, rho, Cp and R. Okay, yeah. So putting down the values, we get the value of T as 474.3. Okay, please calculate and do let me know.
Ma'am, answer will be in Kelvin, na?
Yeah.
So 200 degrees Celsius.
Okay, so you're getting the right answer. Okay. Others, you're able to calculate?
Ma'am, 473 point.
Perfect, perfect. You're getting the right answer. Okay, fine. So let us move on to the next problem statement. Okay, so the temperature
Hello,
of the
ma'am.
meatball after 1 hour. Yeah, somebody saying something? Sunny, I guess you.
Ma'am, they didn't mention anything regarding the unsteady flow. The where how we will find the we are going to use this particular formula?
Okay, okay. This is a nice question. Okay, see, Abhi, if typically when we are, dealing with such type of problem statements now, you have to take it. Basically, see, it is all about आप लोगों को इसमें क्या दिया है? If that is a steady state flow, what is the difference between a steady state flow and unsteady state heat transfer? What is the main difference? Yes.
Ma'am,
I
generally
mean,
this is
steady state, whatever heat is in, that is completely out in steady state.
Okay, and in case of unsteady state?
Some amount of heat is accumulated, or yes,
Mhm.
ma'am. And
there is change between.
some are given out. Some heat is given out.
Others?
Ma'am, in unsteady state, temperature is a function of only time, and it's not considered a function of distance.
Good. Others? And I would like to know the answer from your all of you. Those who were already been able to solve this particular problem statement, how did you get to know he will be using this particular formula?
Ma'am, because there is nothing given about uh, uh, distance or like surface temperature like that. Just directly temperature is given, and if we calculate the BAT number, it's very less than 1. So we can use this lump capacitance method to solve this.
Okay, fine. Others?
Ma'am, in
Do we
steady
have any
state,
answer?
ma'am, in steady state, is the temperature remain constant all the time in my opinion? I may be
Temperature
wrong.
remains constant in case of steady state. Okay. Any other opinion we have? Okay, fine. Okay. So, as for now, tomorrow we'll be discussing about this particular thing. But before we discuss, do study about steady state heat transfer, unsteady state heat transfer, and what are the numbers associated with it. Okay, what is the relation between, say, Biot number, we have Nusselt number. Okay, we have many dimensionless number which are associated with the heat transfer. Okay, you have been through the PPTs or you have been through the study material whichever has been provided for heat transfer. Please go through it. This is a very nice question. Because whenever you are solving any particular numerical, आपको कौन सा formula से जाना है, even in case of fluid flow, we have laminar flow, we have turbulent flow, we have transitional flow. Okay, but which one to use? I was very happy because there was no question which arose for this because it was very clear. Reynolds number, if that is less than 2000, that is laminar, ज़्यादा है. तो turbulent है, बीच में है तो transitional है. Okay, but for this particular thing, be prepared, we'll be discussing it. Okay, yeah. So as for now, we will be proceeding with the next problem statement. Have you solved it? Again, this is very easy. Could you able to solve this?
Yes,
And what was
Yes,
the
ma'am.
answer?
Yes, ma'am.
Yeah, what is the answer?
10.
yes, ma'am.
Others? Same? Okay, so this is a very simple problem statement. So we will quickly go through. Okay, but for those who are not present, they might be going through the recording. Okay, so for them, I'll be quickly going to this particular problem statement. Okay, let us not invest much of the time for this. Okay, so the problem statement is the rate of heat transfer from a metal plate is 1000 watt per meter square. The surface temperature of the plate is 120 degrees Celsius and the ambient temperature is 20 degrees Celsius. The convective heat transfer coefficient using Newton's law of cooling will be what? Okay, so we have been asked to calculate the convective heat transfer coefficient. Okay, yeah, so we will pen down first what is given. Okay, so we have been provided with the Q. We have surface temperature as Ts. We have ambient temperature as TA. Okay, and the area considered here is unit area. Okay, the area is unit area. Okay, so and we have been asked to calculate the H, the convective heat transfer coefficient. Okay, so we have the formula for the rate of heat transfer for convective heat transfer. Okay, so Q by A. Since the value of Q which has been given to us is what? 1000 watt per meter square. So that is in terms of per meter square, that is unit area. So the value of Q by A here will be 1000. Okay, 1000. So Q by A is equal to H into del T. To calculate the value of H, we will be dividing the value of 1000 by this delta. Yeah, we'll be dividing the value by this difference. So substituting the values, we get the value of H, we get the value of convective heat transfer coefficient as 10 watt per meter square per degree. It should be Kelvin, it should be Celsius, all same. Okay, since this deals with the temperature itself, the temperature difference itself. Okay, whether the difference is in degree Kelvin or whether the difference is in degree Celsius, that doesn't matter. Okay. Yeah. So let us move on to the next problem statement for the day. Yeah. So this particular problem, okay, quite lengthy one. Have you solved it? Did you get the answer? What is the answer?
Ma'am, is the answer 19?
Okay,
approx
others?
19.
Okay, no worries, no worries. Others?
Ma'am, I'm getting 2.217.
Ma'am,
Who got
2.2.
this answer?
Anjali.
Anjali got 2.2. Then Shikha got 2.1. Then
No, ma'am,
Ayush, you got
2.2.
2.2
19
itself.
point something. I guess
Ayush
I'm
got
wrong
19
somewhere.
point something. Ritin, Josh, Sunny, Samir, did you get any answer?
No, ma'am. Not. I haven't
Okay,
able to
fine,
solve
no
this.
No,
worries.
ma'am, I can't able to solve it.
Okay, fine. Okay, fine. ठीक है? Yeah, so very good, Anjali. Very good, Shikha. Answer is correct. Okay, so let us just quickly go through the problem statement. We will be focusing more onto the answer. Okay, we'll be focusing more onto the solution part. So a mixed fruit beverage with 12-degree bricks having specific heat of 4298 joule per kg per Kelvin is being heated from 30 degrees Celsius to 95 degrees Celsius for pasteurization at a flow rate of 1000 liter per hour in a tubular heat exchanger. Steam at 100 degrees Celsius is used as heating medium, which is converted into condensate at 100 degrees Celsius if the density of beverage is 1075 kg per meter cube and the latent heat of steam at the given temperature is 2257 kilojoule per kg, the mass flow rate of steam is what? Okay, the mass flow rate of steam is what? Okay, so as you can see, this is a typical example of a heat exchanger, pasteurization. Okay, basically pasteurizer. तो यहाँ पे क्या है? We have been provided with the two streams. Okay, दो stream है यहाँ पे, right? One stream is of the fruit beverage. Now that fruit beverage is being heated from one temperature to another temperature, right? यहाँ पे temperature बढ़ रहा है. Okay, now the other stream is of steam. Okay, the other stream is steam. So ideally, the temperature of steam should, like, there is some heat transfer happening. Somehow there is no difference in temperature here. The steam at 100 degrees Celsius is used as heating medium, which is converted into a condensate at 100 degree Celsius. Okay, now यहाँ पे there is this heat transfer. Heat is transferred from high temperature to low temperature, right? So the heat is being transferred from steam to our juice, our mixed fruit beverage. Okay, so in this case, अभी क्या होगा? The value of Q, the value of rate of heat transfer, okay, that we are calculating with respect to the beverage will be as same as what we are calculating with respect to the steam. Okay, so जो rate of heat transfer है दोनों में with this particular stream, like the rate of gain of heat by fruit beverage will be the rate of heat transfer wherein the steam is losing its temperature, or the rate of heat transfer from steam to fruit beverage will be same. Okay, and we have already been provided with the flow rate for mixed fruit beverage, right? Flow rate for the beverage has been provided to us as 1000 liter per hour, and we have been asked to calculate the mass flow rate of steam. Okay, तो हम लोग पहले fruit beverage का जो भी है rate of heat transfer that we will calculate, that Q will be exactly same for steam, and by using the formula we'll be calculating the value for the mass flow rate for steam. Okay, got it? Getting it? Okay, so let us pen down what is provided first. Okay, yeah, so for beverage. Okay, so we'll be solving it. One for beverage, the value of Q for beverage, and the value of Q for steam. Okay, the value of Q for beverage will be using the formula, and we'll be using the similar formula for value of Q for steam. Okay, yeah, so हम लोगों को क्या दिया है यहाँ पे? Volumetric flow rate. Okay, volumetric flow rate is given as for the beverage is being heated from 30 degrees Celsius to 95 degrees Celsius for pasteurization at a flow rate of 1000 liter per hour. Okay, 1000 liter per hour. Okay, so we can convert it to meter cube per hour. Okay, so 1000 into 10 raised to minus 3 meter cube per hour. Okay, the value of rho is, the value of density is 1075 kg per meter cube, and the value of Cp, yeah, the value of Cp is again mentioned here as 4298 joule per kg per Kelvin. Okay, that is the specific heat. Okay, that is the specific heat for the mixed fruit beverage. Okay, now how we can calculate the mass flow rate for beverage? Okay, all the calculations we are doing here are with respect to the beverage only. Okay, now the mass flow rate of beverage, how we can calculate? We have provided with the volumetric flow rate. Okay, simple formula for density is equal to mass upon volume. Okay, so to get the volume mass flow rate, we will be multiplying the volumetric flow rate by density. Okay, by density. Okay, so 1000 into 10 raised to minus 3 multiplied by 1075, we get the mass flow rate as 1075 kg per hour. Okay, the value of mass flow rate will be 1075 kg per hour. Now, we know the formula for rate of heat transfer as mCp dt. Yeah, mCp del T. So put the values. We have the value for mass flow rate as 1075. Cp का value दिया है 4298 multiplied by the temperature difference. Yeah, the beverage is being heated from 30 degrees Celsius to 95 degrees Celsius. That is 65. Yeah, so 1075 into 4298 into 65. That is the value of Q for beverage. Okay, that is the value of Q for beverage. Okay, now this flow rate remains the same.
Ma'am, but temperature is different in the question.
Temperature is different, matlab?
50 to 7 it is.
No, that is
Actually,
30 degrees Celsius. The beverage is being heated from 30 degrees Celsius to 95 degrees Celsius.
which question number is it, ma'am? I'm confusing.
We're on
this.
question number 5.
Okay. Sorry, ma'am. Sorry. I'm really sorry.
Okay, no worries. Did you get the question?
Yes, ma'am.
Okay, fine. All of you? Did you get the value of Q?
Yes, ma'am.
Okay. Okay. So in case of steam, now what we know, the value of Q, yeah, the value of Q is equal to mass flow rate multiplied by the latent heat of steam at given temperature. Okay. So we have the formula as Q is equal to M into L. L stands for the latent heat. Yeah. So put the value of Q, put the value of L. Since the value of L here is 2275 in kilojoule per kg, we will be converting it to joule per kg. Okay. So multiply it by 10 raised to 3.
मैम
Okay.
इसमें
So
फॉर्मूला भी लग सकता है क्या?
yeah, the formula is Q is equal to M into L. The formula for Q is equal to your mass flow rate multiplied by the latent heat. Multiplied by the latent heat of steam. Please pen it down if you don't have. Okay, yeah. So put the values. So you get the value as 132.01 kg per hour. Okay. Now since the value is in kg per hour, and what we have been asked to calculate? We have been asked to calculate the mass flow rate of steam in kg per minute. Okay. So divide it by 60. You get the value. Everyone getting the same? Okay, fine, perfect. Ayush, you got it? Ritin, Sunny, Samir, those whoever could not solve it?
Yes, ma'am.
Okay, fine. Perfect.
Yes, ma'am.
Okay, perfect. So I think we should move on with the next problem statement now. Okay. Next one is again very easy one. Okay. Yeah. So I will read out the problem statement first. Okay. Then we will be going to the solution. So fruit juice was cooled in a tubular heat exchanger from 50 degrees Celsius to 7 degrees Celsius using water at 2 degrees Celsius, which gets heated to 5 degrees Celsius. Okay. तो यहाँ पे temperature कम हो रहा है, यहाँ पे बढ़ रहा है. Okay. So again there are two streams. Now assume Prandt's number to be 0.72, Reynolds number 20,000, and thermal conductivity 0.6 watt per meter per Celsius, and no viscous effect. If pipe diameter was 10 centimeter, the convective heat transfer coefficient is what? Okay, the convective heat transfer coefficient is what? So हम लोगों को क्या निकालना है? The value of H. Okay, we have been asked to calculate the value of H. Okay, and there is one simple formula, okay, which is being used to solve all such kind of problems. And even while we have studied the theory part, for the heat transfer, we have used that formula many a times. Okay, if you have been through the study material, you would have found the particular formula. Okay, yeah. So how many of you have been able to solve it, and what is the answer?
Ma'am, is the answer 19 point something?
Okay, who's that?
Ayush?
Ma'am,
Sorry.
345.06. Yes.
Yes,
How
ma'am.
much you are getting? Shikha and Anjali, 340.
5.
345.06.
Okay, fine. Others, Ritin, Josh, Ayush ka to sun liya, Sunny, Samir.
Doing, ma'am.
Why you didn't solve the problem?
345.1. 345, ma'am.
345 for you, Sunny. Okay, very good. Ritin.
340 something.
Okay, fine. Josh, do solve the problems, huh?
Ma'am, please
आप लोग-
explain this one.
Yeah, I will explain. Don't worry. I will explain. Okay, but I want all of you to solve it first. Okay, जो आपको दिया जाता है, solve it. हम लोग कहाँ पे mistake कर रहे हैं, वो समझना बहुत जरूरी है. Okay, rather than just solving the numerical. Okay, it is good to make mistakes. ठीक है? Okay. So this was the problem statement. यही था ना? Yeah. We are on to this. So हम लोगों को given क्या है? Okay, given is Prandt's number, Reynolds number, the value of D and the value of K. Okay, and the value of K, right? Yes, यही दिया है. Thermal conductivity दिया है. दोनों dimensionless numbers we have been given, provided with, and the diameter. Okay, now the simple formula which is being used to calculate all these things is the formula for Nusselt number. Okay, what is the formula for Nusselt number? The widely used formula is Nusselt number is equal to HD by K. Okay, where your H stands for the convective heat transfer coefficient, D is the diameter, and K is the thermal conductivity. Okay, Nu is equal to HD by K. Okay, many a times it might happen कि you are provided with the value of Nusselt's number and आपको convective heat transfer coefficient निकालना है, और vice versa. Okay, convective heat transfer coefficient दिया है, आपको Nusselt number निकालना है. Based on that Nusselt number, you might be asked to calculate either Reynolds number दिया है, you might be asked to calculate the Prandt's number. Okay, it might happen. So this relationship is always used. Okay, wherein Nu stands for HD by K, Nu also stands for 0.023, Reynolds number to the power 0.8, and Prandt's number to the power 0.3. Okay, so we can calculate the rate of convective heat transfer by using the formula for Nusselt number. Okay, so put the values. We have already been provided the value of Reynolds number as 20,000 to the power 0.8 multiplied by Prandt's number to the power 0.72 to the power 0.3 and multiplied by 0.023. Okay, you get the value of Nusselt number as 57.51. Okay, so put this value. So 57.51 is equal to HD by K. Cross multiply and calculate the value of H. Getting the answer? So the value of H will be, so the value of H will be 57.51 multiplied by 0.6 divided by 0.1 as 345.066 watt per meter square per Celsius. Okay. Let us move on to the next problem statement.
Yes, ma'am.
Okay.
Actually, I didn't knew this formula.
Don't tell me. You don't have the study material? You didn't find
Yes,
through the
ma'am, I have.
PPTs? Then it is mentioned.
Yes, ma'am. Yes, ma'am.
Okay. Yeah, so chalo, let us move on to the next problem statement. Again, this one is quite easier one. We will be going to the solution, don't worry. Okay, whether you're able to solve it or you're not able to solve it, there are many students, those who are available online as well. Those who will be looking.
Yes, ma'am.
Yeah,
Same.
I think
Yes, ma'am.
yesterday only we solved the similar problem.
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay, fine. So I'll just skip it. Okay. Okay, so this is the answer. So next problem. Anybody who could solve this?
Yes, ma'am.
Yes, ma'am.
What is the answer?
12.59.
Yes, ma'am.
Okay.
12.591.
Okay.
Yes, ma'am.
Others?
Same.
Great. Same. Perfect. Perfect. Others? Okay, fine. So let us go through the solution part. Okay, as I could see, majority of you have been able to solve this particular thing. Okay, yeah. So the problem statement is an orange juice flowing at 0.80 kg enters a countercurrent double pipe heat exchanger at 20 degrees Celsius and leaves at 72 degrees Celsius. Inlet and outlet temperatures of the hot water used as heating medium in the exchanger are 81 degrees Celsius and 74 degrees Celsius respectively. Okay, the inlet and outlet temperature. Okay, since this is an example of a counter current double pipe heat exchanger. Okay, so there are two temperature differences we have. एक enter कर रहा है 22 डिग्री सेल्सियस पे and leave कर रहा है 72 डिग्री सेल्सियस पे, and the other one, the hot water is entering, the inlet temperature is 81 degrees Celsius and the outlet temperature is 74 degrees Celsius respectively. Okay, now the specific heat of the orange juice is 3.74 kilojoule per kg per Kelvin and overall heat transfer coefficient is 492 watt per meter square per Kelvin. Now what we have to calculate is the heat transfer area, or the surface area for the heat transfer is what we have been asked to calculate. Okay, so we'll be using the same formula. Okay, we'll be using the simple formula for Q, the rate of heat transfer. Okay, we have two formulas to calculate the rate of heat transfer. Q is equal to, or Q by A is equal to U del Tm, UA del Tm. Q is equal to UA del Tm del T, and Q is also is equal to mCp del T. Okay, Q is also equal to mCp del T. Okay, so we will be dealing with these two formulas here. So let us pen down. So the heat transfer surface area can be given as A is equal to Q divided by U into del Tm. Del Tm is log mean temperature difference. Okay, del Tm is log mean temperature difference, where Q stands for the rate of heat transfer, U is the overall heat transfer, del Tm is the log mean temperature difference. Also, what do we know? The rate of heat transfer is equal to mCp dt. So dt deals with T2 minus T1. Okay, T2 minus T1. For here, it is for the orange juice. Okay, that is for the orange juice. Okay, where m is the mass flow rate. We have been provided with the orange juice mass flow rate as 0.80 kg. Okay. Then the value of Cp, specific heat of liquid. The value of Cp is 3.74, which has been provided. Then again, we have been provided with the inlet temperature and outlet temperature. Okay, now again, since we are dealing with the difference only, it is absolutely fine to deal with degree Celsius. Okay, or degree Kelvin, whichever is been provided. Okay, yeah, so we can calculate the value of Q as mCp dt. Put the values. The value of m is 0.8. The value of Cp is 3.74 and T2 minus T1. Okay, the juice is entering at 20 degrees Celsius and leaving at 72 degrees Celsius. Okay, that is 72 minus 20. So that stands for 150.584 kilojoule per second. We can convert it to joule as 150,584 joule per second. Okay, yeah, so put this value in the value of heat transfer surface area. A is equal to Q divided by UA del Tm. Okay, now how to calculate the value of LMTD? LMTD is the log mean temperature difference. Okay.
Yes, ma'am.
Okay. So put the values. Put the values. The value the difference will be, we'll be substituting the water outlet from your juice inlet. I hope you know how the countercurrent heat exchanger works, and we'll be substituting the value of juice outlet. No, we'll be substituting the value of water inlet from that of juice outlet. Okay, and the log of its ratio. Okay, log of the ratio of these differences. Okay, put the values.
Hello, ma'am.
Hmm.
Ma'am, the del TM value is different. It's coming 25.1 something.
That
Yes,
LMTD
ma'am. No,
25.
Yes,
ma'am.
ma'am. Yes, ma'am.
Yeah. And the area is also different coming.
Okay, so I think, I
Area
guess you're getting 12.13.
12.
12.13.
12.59.
It should be
12.6
12.13 then.
around.
It should be 12.13 now. If you're putting like the value of LMTD coming out to be 25.22. Yeah, even I solved it. Even I found I have made a mistake here. Yeah. So the value of LMTD is 25.22. Even I'm getting the similar value. And the value of A here will be 12.13. All of you are getting the similar value?
Yes, ma'am, somewhat.
You're 12.
12.59.
Achha. So that is
Yes,
12.13
ma'am.
for me.
Okay, ma'am, we are
Okay,
getting
fine,
And
fine.
the
LMTD
value of LMTD is
25.11.
25.11. Yes.
Achha, for me it is 25.2. Okay, fine, fine. This much variation, okay. ठीक है? Yeah, everybody clear on this particular thing?
Yes, ma'am.
Okay. Yeah, so let us move on to the next problem statement. Yeah, so typically next is not the problem statement. It is a theoretical problem. Okay, and I guess सबको इसका आंसर आना चाहिए. ठीक है? So the problem statement, the theoretical problem is, which of the following expressions represent the Reynolds number of a fluid flowing through an uniform circular cross-section pipe? What is the answer?
A and B.
Others?
A and B, ma'am.
Okay, perfect. Okay, fine, fine. So the answers are A and B definitely. So the A is in terms of dynamic viscosity and B is in terms of kinematic viscosity. Okay. Yeah, so somehow I have put a little bit of explanation here. I don't think there is any number, but still I'll just go through for those who will be going through the recording. So Reynolds number is a dimensionless measurement. Okay. So this fluid viscosity can be measured in terms of dynamic viscosity as well and the kinematic viscosity as well. Okay, and it simply involves multiplying it by the density. Okay, multiplying it by the density. Okay, when you're using the dynamic viscosity, there will be the density, and like while we're converting the dynamic viscosity to the kinematic viscosity, we again divide it by the value of density. Okay, yeah. So the answers are option A and option B. Okay, yeah, so moving on to the next problem statement. Yeah, this is the very easy. How many of you have been able to solve it? What is the answer? Let me know the answer.
2.29 is the answer.
Okay, others?
2.3.
Okay, perfect. Okay, so let us quickly go through. In a cold storage plant, 5000 kg potato having a constant specific heat capacity of 3.65 kilojoule per kg per degree Celsius are cooled from 28 degrees Celsius to 2 degrees Celsius in 24 hours. The heat of respiration of potato per 24 hour is 3.12 kilojoule per kg during the storage. Okay, there is this heat of respiration. Assuming the efficiency of the storage plant to be 70%, the capacity of the plant in ton of refrigeration will be what? Okay. Yeah, so ultimately हम लोगों को capacity tonnage में ही निकालना है. I don't know why we have been provided with the difference of 1 ton of refrigeration is equal to 3.517 kilowatt. Okay, yes, still let us go through the problem, the solution. Okay, So we'll be penning down first whatever has been provided. We have been provided with the value of M. The mass is 5000 kg of potato. The value of Cp, specific heat capacity, to be 3.65 kilojoule per kg degree Celsius. The temperature difference, del T, is 26 degrees Celsius. Yeah. So how? Because the potatoes are being cooled from 28 degrees Celsius to 2 degrees Celsius during storage. So what will be the del T? 28 minus 2, that is 26 degrees Celsius. हम लोगों को दिया है heat of respiration as 3.12 kilojoule per kg. Okay, and yeah, that is the heat of respiration. So what will be the heat of respiration? Since this is in per kg basis, so for 5000 kg of potatoes, the heat of respiration will be multiplied by 5000. Okay, multiply it by 5,000. So 5,000 into 3.12 will be 15600 kilojoule. Okay, that is the heat of respiration. Okay, that is the heat of respiration. But since this is a cold storage, there is also an involvement of heat transfer. Okay, so how we can calculate that? Q will be is equal to mCp dt. Okay, we have the value of M, we have the value of Cp, we have the value for del T. Put the values. Okay, by putting the values, you get the value of Q as 474500. Okay, yeah, now we have, so we have both the heats. Yeah, we have both the heats. So the total the total heat transfer will be the heat transfer by respiration, and by our heat transfer will be QR plus Q is equal to 490100 kilojoule. Okay. Yeah. So we will be converting this kilojoule to kilowatt. How to convert it? 1 joule per second is equal to 1 watt anyhow. So the conversion is all same. But हम लोगों को क्या करना है? Per second. Okay. This is 1 joule per second. We have to convert it in that basis. Since this is for 24 hours. Okay. This temperature difference del T is 26 degrees Celsius in 24 hours. Okay. So we will be converting it to per second. So divide this Q by 24 into 60 into 60. Okay. That will be in seconds. So you get the value as 5.67 kilowatts. Okay, 5.67 kilowatts. Okay, now since the efficiency is 70%, calculate the value of Q at 70%. 5.67 into 0.7. Okay, everybody got the answer?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So, take it quickly. So we have next this particular problem, this particular theoretical question. What is the answer here?
A and C.
Okay, perfect. Okay, everybody is in accordance. So this is nothing but the simple, formula depiction. And we just have to pick the correct one. Okay. So for those who doesn't know, Reynolds number ka formula, Nusselt number ka formula, Smeed number ka formula is this, and Biot number ka formula is this. Okay. Yeah. So the answer for question number 11 is A and C. Okay. The answer is A and C. Okay. Fine for today. Okay. ठीक है, so अभी जो बचे problems है, we will be solving it in the next session. Okay, tomorrow's session. Okay. Along with this, you will get another set of questionnaire for tomorrow. that you can solve. Okay, and again we'll be having the solution for those problems as well. Okay. Yeah. So
Okay,
can I
ma'am.
take your leave now?
Yes, ma'am.
Okay.
Yes,
Yeah.
ma'am. Thank you, ma'am.
Yeah. Thank you and good night, all of you.
Ma'am.
Good night, ma'am.
Yeah. Good
Good
night.
night,
Good
ma'am.
night,
Good
ma'am.
night, everyone. Good night.